All right, we're looking at the solutions for the integration practice test. So be sure you got your formula sheet, your calculator, and your single-sided A4 cheat sheet, handwritten. All right, first off, we just got to calculate a whole bunch of integrals. So this first bit, 4x squared, becomes 4x cubed over 3. This becomes 2x squared over 2. And then this last bit becomes x plus c. C is a real number. You could simplify that middle term, but you don't need to. It says at the start of the question. This one here, I want you to split up the integral. So 1 over x squared is the first bit, and then x over x squared is the second bit. So fractions do split up like that. So this is going to be the integral of x to the minus 2 plus, and then that other bit simplifies down to 1 over x, or x to the minus 1, depends what you want. This one here becomes x to the minus 1 over minus 1. And if you try and do the same for that bit, you'll get x to the 0 over 0. Now that doesn't work because you're dividing by 0. This is the special one where you get a log of x. Next one we got here, root of 2x plus 1 is the integral of 2x plus 1 to the power of a half. And then we can use the rule for integrating square roots like this. So you bump up the power like that. 2x plus 1 to the power of 3 halves over 3 halves. But you need to times by 1 over the number with x, so that's 2. Next we've got sine. So sine goes up to minus cos. And we can divide by the number with x. Plus c. C is in R, and I missed that on the last question, plus C. C is in R. All right, next we need to do this definite integral by hand. So 4x cubed goes up to x to the 4, or 4x to the 4 over 4. And then 2 goes up to 2x. And this is going to go from 1 to 2. So that first term simplifies to x to the 4. And then that's going to be 2 to the 4, take 2 times 2. So that's the first bit. And then we've got 1 to the 4, take 2 lots of 1. So that's 16, take 4, take away, and then that's 1, take 2. So that becomes 12, take minus 1. So that's 13. Really importantly, you can hit math on your calculator, that's F4, and you can go integral just to double check this one. So you've got 4x to the power of 3, take 2. And then we want to integrate that from 1 to 2. So yes, you get 13. No units squared on this because it's not an area, it's a definite integral. Okay, next we got to differentiate this. So to y dx, e will stay the same. So e to the x cubed plus 1 doesn't change, but you need to times it by the baby, that's 3x squared. Therefore, so from part 1, we know the integral of 3x squared e to the x cubed plus 1. I'll just rewrite this up here. So now if I integrate that answer, then I should get what we started with, e to the x cubed. Okay, so we can pull the 3 out. Well, first of all, before we pull the 3 out, we got to say from a. Then we can pull the 3 out. So 3 integral x squared e to the x cubed plus 1 dx is e to the x cubed plus 1. So this is properties of integrals. And then we can divide by 3. So that's x squared e to the x cubed plus 1 dx is a third of e to the x cubed plus 1. Now I need a plus c on the end here, but that's different to the one above it. So I'm going to call this one plus c1. C1 is a real number. So if you want, C is actually C1 over 3 because we divided out by 3 at that last bit. Next, we had a conjecture question. So show that the area there is 4/3. So first of all, we need to find the x-intercepts. So that's 0 equals f of x. So 0 equals 1 take x squared. So x squared equals 1. So x is plus or minus 1. Therefore, the area is going to be the integral from minus 1 to 1 of 1 take x squared. So that's going to be x take x cubed over 3 from minus 1 to 1. and that's going to be 1 take 1 cubed over 3, take away, and then it's minus 1 take minus 1 cubed over 3. Okay, so then this is 1 take a third, so that's 2/3 there. Take away, and then this is minus 1, and let's see, that's 1, 2, 3, 4 minuses, so that becomes plus a third, minus 2/3. So that is 2/3 plus 2/3, so this is 4/3. Square units as required. Cool. All right, there's a table. We need to make a conjecture. So it looks like, well, there's only even numbers, first of all. We'll talk about that later. It looks like whatever's on the top of the fraction is just double whatever that k value is. So the area contained between y equals 1 take x to the k and the x-axis is, now it looks like 2k on the top, and it might look like 1 more than k on the bottom, so k plus 1. For all even whole numbers, for all even whole k values, as you conjecture. Okay, prove or disprove it. So we need to find the x-intercepts first, just like what we did before. So this is going to be 0 is 1 take x to the k. So x to the k is 1. So x is the kth root of 1, plus or minus. Yeah, if you're taking an even root, you do get a plus or minus. If you're taking an odd root, you don't, since that's even, so as k is even. Therefore, x is plus or minus 1. So the roots are still the same. And if you do a graph, and I'd actually recommend you do this, so we just delete out those. You look something like 1 take x to the 6 or something like that. So we'll draw that. And if we look at the window, I'm just going to hit standard. You can see that the x-intercepts are still 1 and minus 1. So therefore the area is the integral from minus 1 to 1 of 1 take x to the k, and you just churn through that integral like normal. So this is x take x to the k plus 1 over k plus 1 from minus 1 up to 1. So that's 1 take 1 to the k plus 1 over k plus 1. And then that's take away 1 take, minus 1. Take minus 1 to the k plus 1 over k plus 1. Okay. So this is, now, as k is even, k plus 1 is odd, therefore minus 1 to the power of k plus 1 is minus 1. So I'm just going to call this thing star. And then we'll use that here. So this is 1 take 1 over k plus 1. Take. So this is going to be minus 1. Now, this top becomes minus 1 from star. So take minus 1 over k plus 1 from star. Cool. And then we can just work through this. So 1 take 1 over k plus 1. This expands out to a plus 1. And then this last bit, 1, 2, 3 negative. So minus 1 over k plus 1. Okay, so this is a 2 take 2 over k plus 1. And then if we cross multiply, I'm going to run out of space. So this is 2 lots of k plus 1 take 2 over k plus 1. So this is a 2k plus 2 take 2 over k plus 1, which is 2k over k plus 1. There we go, we finished the proof. Don't forget, these tests do have an extra page on the very back of them that you can use for extra space. So do label the question if you need that. But yeah, we got the conjecture. So find the area as k goes to infinity. So it's a little bit weird, this one. So it's hard to spot from the conjecture, but if we take it from this bit, so area is 2 take 2 over k plus 1. So as k goes to infinity, 2 over k plus 1 would go to 0. Therefore, the area would go to 2 take 0. So it's basically that bit is going to 0, which is 2. And if we look at this and do like 1 take x to the power of 100 or something, and we draw that, and it's basically a rectangle. So you can go G-solve, you can look at integral, go mixed. You just hit enter there and you hit enter over here. The area will basically be 2, or like 1.98. So the area approaches 2 as k approaches infinity. You get a rectangle shape. Explain why k was required to be even. So if we look at the graph of like 1 take x cubed, and draw that, looks something like this. If k is odd, no area gets enclosed. So it looks like that, e.g. So yeah, there's no area to be enclosed. Whereas if you have an even number, that last bit flicks down and then you get an enclosed area. So there's the conjecture. All right, we got this. F of x equals root x. Draw 4 rectangles between x equals 1 and x equals 5 for an upper estimate. So you will use a rule for this. But basically, go. 2 marks, done. Calculate the upper estimate. So U4 equals, so it's all of them are 1 times, and then you're essentially using the right hand side of the rectangle to get the heights, because that's the higher bit. So it's root 2. Well, in general, the function is root x. It's root 2 for that first bit. And then we got to root 5. All right, so we can work out what this is. Root 2 plus root 3 plus root 4 plus root 5. Cool. So that roughly equals 7.38 square units. Excellent. Calculate the lower estimate, L4. L4 roughly equals, well, exactly equals. So I didn't ask you to draw them, but if you did, the lower rectangles would be the ones underneath. So using the left-hand side to get those. Okay, so it's 1 times root 1 plus 1 times root 2 plus 1 times root 3 plus 1 times root 4. And don't worry about the times by ones, but if you go root 1 plus root 2 plus root 3 plus root 4, 6.14 or 6.15. All right, find a better estimate. So area approximately equals the average, so U4 plus L4 over 2, roughly equals 7.38 plus 6.15 all over 2. Now I'm going to use the original numbers, so we'll do a fraction. 7.38, 2, 3, 2, 3, 4, 7, plus 6.14, 626, 437. Bit annoying that you have to do it, but it's really important that you, whenever you reuse a number, you don't use a rounded version. So it's about 6.76 square units. And find the exact area. So area is going to be the integral from 1 to 5 of root x, which is the integral from 1 to 5 of x to the half, which is x to the power of 3 halves over 3 halves. And dividing by 3 halves is like timesing by 2/3. So I'm actually going to show you a cool thing. You can pull 2/3 out the front. It says you're putting it in both terms. All right. So x to the 3/2 is x root x. Like that, from 1 to 5. So this is, if you're wondering why, that's x to the 1 and x to the half. They add together for 3/2. So you get 2/3 of 5 root 5, take 1 root 1. So you essentially get 2/3 of 5 root 5, take 1. So if we map that out, you're going to get 10 root 5 over 3, take 2/3. Now, how do we know we've done this right? Well, you can do that. 10 root 5 over 3, take 2 over 3. And you get that, 6.786, which is actually very close to our best estimate. Very, very close. So that's already a good sign. But if you want to be really sure you get it right, integral. So it was root x from 1 to 5. And if I do this, I should get exactly that number. Yeah, I do. So that's good. And we just need square units. Now, since they were asking for the exact area, no approximates. I want 10 root 5 over 3. Take 2/3. Really important. All right, next we've got this function. So basically 2 to 8 is minus 5. 5 to 8 is 8. So what's 2 to 5? Well, the integral from 2 to 8 would be like splitting up. So the integral from 2 to 5 plus the integral from 5 to 8 plus a whole bunch of notation. So we need our f of x's. Therefore, we know what two of these three things are. Minus 5 is the integral from 2 to 5 plus 8. Therefore, the integral from 2 to 5 would be minus 5 take 8, rearranging the equation, which is minus 13. Cool. All right. Calculate the integral from 8 to 5. So the integral from 8 to 5, this is a property of definite integrals. If you flip the two numbers, you just get negative. So it's negative of what that integral was. And this is going to be negative 8. Cool, because it says 8 up there. Next one, the integral from 5 to 8 of f of x plus 2x. So we can actually split this into two integrals. So that's the integral from 5 to 8 of f of x plus the integral from 5 to 8 of 2x. Now we already know what one of these integrals are. It's 8. So we're going to put 8 for that bit. And then it's 2x squared over 2. So essentially it's just x squared there from 5 to 8. So this is 8 plus 8 squared take 5 squared. And if you want, you can actually just whack that straight all in a calculator. Bam, 47. And no square units because it's just a definite integral, not an area. Evaluate this integral from 1 to 0. So we can go integral. Well, to get to that menu, it's... Actually, no. I'll tell you what I'll even do. I'll graph it. So 30... And then it's e to the power of minus 2x. Oops. 30 e to the minus 2x. Draw that. We can use a window to help. So the window seems to go from 0 to... Well, that window goes from 0 to 4. And then we go from 0 to 40. Have a look at that. There we go. And then G-solve across integral. Normally I'd say mixed. Now, mixed almost always works. If it throws you an error, then you just use the first one, integral. So we're going to go from 0 to 1. 12.969. Or the integral from 0 to 1 of f of x dx roughly equals 13.0. Illustrate and label your answer. So that would be shading in that area from 0 to 1, and then area equals the integral, which roughly equals 13.0 square units. So that's part B. So that's what they mean, and from 0 to 1. Cool. Now we got to work out each of these. We already had this one. So that was 12.970. Yeah. The integral from 0 to 3, 14.963. Is that a 3 after? I can't tell if that's a 3 or an 8. I think it's an 8. 14.963. Very difficult to tell. If you can't do that for whatever reason, so I could add just like a little bit off to the bottom of my window. Not an X, what am I doing? On Y, minus 10. And then we could just get a clearer view of what that integral actually said. So 0 to 3. Yeah, wasn't it? Cool. And then if we go integral from 0 to 5, your calculator is going to throw an error. Now that's because our window isn't big enough. So you go to window, make it at least 5. I'll just make it 6. And then we're going to go integral 0 to 5. Bam. 14.999. Use your table to make a conjecture. So you could say something like, as a goes to infinity, the integral from 0 to a of f of x goes to 15. And if you want to be really fancy, you can say from below. You don't need that bit, but if you have it, that means from below. Now we should probably define f of x because this is a conjecture statement. So let f of x equal that. E to the minus 2x. Yep. Wonderful. Prove or disprove your conjecture. So the integral from 0 to a of f of x is the integral from 0 to a of 30e minus 2x, which is, so that's going to be 30e to the minus 2x over 2 is the antiderivative. The 2 comes from the number with x. So that is 15e to the minus 2x from 0 to a. So that's 15e to the minus 2a. Take away 15e to the minus 0. Now I should have divided by minus 2 there because it was minus 2 with the x. There we go, that's fixed up. E to the 0 is 1. So this is minus 15e to the minus 2a plus 15. So this integral is 15 take 15e to the minus 2a. Okay, now I need to think about it over here for a little bit. So as a, well, first of all, we could rewrite that as 15 take 15 over e to the 2a if we want. So as a goes to infinity, 2a will also go to infinity. Therefore, e to the 2a will go to infinity. Therefore, 15 over e to the 2a will go to 1 over infinity, essentially, which will go to 0. Therefore, 15 take 15 over e to the 2a will go to 1 take 0. So it goes to 1. So there we go. No, I lied. 15 take 0, which is 15. Now, note goes to 15 from below, as always, less than 15. So you can make a little note about that. Cool, that's how we prove the conjecture then. All right. And it's always less than 15, as it's always 15 take a positive number. All right. Calculator question. Kinematics. So let's graph this. You want to make sure you're in radians because it's a trig graph. So sine of x, take x plus 5. If you want to be extra careful, because I'm not exactly sure how the Casio is going to bedmass this, put sine of x in brackets like that, just in case it does like x take x all in the sign. Okay, so we're talking about things in the range of 10 seconds. So maybe let's just look for the first 20 seconds on the graph, and we'll see what that looks like. There we go, and that actually looks pretty good already. Maybe I'll squeeze the window down a little bit. You don't necessarily need to, it just will help me show what the heck's going on for this video. All right, find the initial velocity. So the velocity at 0 roughly equals, well, so trace 0, 5, it exactly equals 5. So the glider is moving up at 5 meters per second, and it's up because positive is up and negative is down. That's what we said in the question. Calculate the total displacement in the first 10 seconds. So you're going to go G solve, you're going to go to integral, and you're going to go mixed 0 to 10. Apparently I can't type today. 10 is the upper bound. There we go. So we've got two numbers there. The first number is the integral. So displacement after 10 seconds roughly equals 1.84 meters right of, well, not right, above, because we're doing an up-down problem, above the starting point. Calculate the total distance, that's the other number, 25.5. Distance, so maybe like total distance traveled in first 10 seconds roughly equals 25.5 meters. I think we're in meters. Yep, we are. At what times does the glider start falling downwards? So this is going to be for the velocity equals 0. So we're going to go G solve root. Try that again. 4.152. So T roughly equals 4.15 seconds. So if you think about this glider, right, it's sort of going to like, wherever I'm throwing it from, it's going up and then it's like doing that sort of, it's a bit of a weird shape, but basically at that point the velocity is 0 because it's not moving up or moving down, and we figured out that T is 4.15. Okay. If the glider starts 1 meter above the ground, find an expression for the displacement. So the displacement is the integral of the velocity. So this is the integral of sine of x take x plus 5. And that's with t's. So, that should be t's in the question there. I'll fix that up on the actual test. Sine of t take t plus 5 to t. And then that's minus cos of t, take t squared over 2 plus 5t plus c. So that's s of t. Now, the glider starts 1 meter above the ground. So basically what you got to do is we've got to sub in s is 1, t equals 0 to find t. So 1 is minus cos of 0. Take 0 squared over 2 plus 5 lots of 0 plus c. Now you got to be careful because cos of 0 is actually 1. 1 is minus 1 plus c. So c is actually 2. So s of t is minus cos of t, take t squared over 2, plus 5t plus 2. All right, now let's graph that. I might graph it here. So minus cos of x in this case, take x squared over 2 plus 5x plus 2. We'll do that. Now that's the displacement graph up there. We got to get more v windows, so maybe let's go up to 20 on the y-max. There we go. And you can sort of see what the glider is doing. Like it's up really high to start with, and then it sort of gradually falls down because it's like gliding and stuff. Funny that. So we can verify a few things immediately. So if we go g-solve max, then it should happen at 4.15 seconds. Max above the top graph. Yes, it does, 4.15 seconds. If we look at, for example, the distance or the displacement in 10 seconds, so if we go trace at 10, 2.83. Okay, that's above the starting point. Now, or 2.84. So hopefully that makes sense. When we did part B, the displacement was 1.84 meters above the starting point. And if it starts already 1 meter above the ground, then it should be 2.8 meters above the ground because it's 1.8 meters above where it started. I'm hoping that makes sense. How long does it take for the glider to hit the ground? You literally just solve. So you go root on the top line and 10.476. And you might, because it's a 2-mark question, a little bit more explanation might be good. So like S of t equals 0 is how you did that. Gritty, all right. Next question. Nintendo is releasing a Magic Art controller. I can't wait. Anyway, you're going to graph this. So it's actually a surge function. People are surging into the store wanting to buy this controller. 50x, and then it's e to the power of minus x. That's the equation. Well, that's actually already a pretty good window. That's nice. So maybe it's 0 to, well, the store's open from 9 to 5, so that's 8 hours, so 0 to 8. And y can go from 0 to 20. And that should give us a really nice graph. Beautiful surge function. Find the approximate rate of people entering at 9:30. So that's going to be essentially r of 0.5 because it's half an hour since the store opened. Got to be very careful. Times in hours in this question. 0.5, so 15.16 or 15.2. 15.2 people per hour. Find where it's entering the highest. So that's g-solve max. 1 and 18.4. So at 10 a.m. there is the most people entering per hour. And that happens to be 18.4 people per hour. It's like the busiest. If the store's open from 9 to 5, how many people entered? So that's just g-solve. You go across to integral. If you hit mixed, it'll give you an... Oh, it won't give you an error. That's nice. So we can just hit 0 to 8. Bam. 49.89. Or 49.8. So number of people. It's going to be the integral from 0 to 8 r of t to t. Which roughly equals 49.8 people. So about 50 people in total. Okay.